Okay, all right. So it's recording. So let's jump into the presentation. Oh, yes. After the presentation and after the demonstration, we will have a dedicated Q&A part. But if you guys already have some questions along the way, please feel free to write them in the chat, and then we are going to go over them after the demonstration. But yes, so CENOS Induction Heating version 4.0, introduction into what is essentially new with the software. So today we are going to do the presentation in a bit more different manner. So I'm going to just show this one slide, and afterwards we are going to go inside the CENOS software itself, because the additions and the new features that we have added to the latest version are actually a lot more better explained directly within the software, not with the presentation. But just to give you guys an overview and an understanding of what actually is new, we have added 4 new features. So CENOS manual mesh interface, possibility to replace CAD files within your system, and motion table values, over which we are going to go in more detail during the demonstration a bit later. We have also included dynamic result processing, which currently allows CENOS and enables actually CENOS to process simulation results after each time step of your calculation, meaning that if by any unlucky occasion your computer crashes or something happens with your power supply or something else, and you are in the middle of your calculation and something happens, from now on you won't lose the progress that you have calculated so far. You will be able to restart the simulation at the exact same place where it crashed, simply because right now CENOS calculates the results and saves them after each time step, not at the end of the simulation as it was before. We have had also a couple of improvements, so some bigger, some smaller, but the ones worth mentioning is, first of all, better convergence for some cases, especially for voltage-controlled cases. We have significantly updated and improved our automatic meshing capabilities that we are using in the from CAD approach, and we have also slightly reworked the advanced result visualization field within CENOS, which I'm also going to show a bit later. And from bug fixes, honestly, I don't even know where to start, because we have changed so much with the version 4.0 that I cannot even list all of them. But some of the highlights for the improvements and the bug fixes for stability and known bugs, the biggest ones include skin layer generation in CENOS Mesh, which previously actually caused problems in the from CAD approach, that you couldn't use the automatically generated mesh simply because of this bug. Then also preview hovering has been fixed. So right now you can actually hover over any kind of boundary settings or volumes within the preview window in the physics setup, and the opposing part, respectively, will highlight. And we have also improved PDF generation stability, because previously, in some specific cases, also PDF generation had some problems. But that's about the overview, or so to say, the summary of the new version is it. So right now, let's get into the actual demonstration. So what I have here is I have opened the new CENOS Induction Heating version 4.0 setup. And what we're going to do is we are going to go through one very standard CV joint setup case in the from CAD approach, and along the way, take a look at what has been improved, changed, and updated. So as with any other setup, we are going to start in the exact same way. I'm going to select my CAD files. So I have prepared, actually, specifically separate CAD files for flux, inductor, and the workpiece, which is in this case is a CV joint detailed with splines. So let us wait until the geometry loads. So this is, as some of you might know, this is one of our most popular and my personal favorite example cases. So we are going to use this today as well. Now I'm going to generate the airbox around my system because I don't have it made up manually. And afterwards, I'm going to need to define the so-called geometry roles. So for those who don't know, the first part within CENOS is to actually define the system that we are going to work with. Now, most of it has already been defined. I need to define the workpiece volume. I need to define the workpiece surface. And I can filter the surfaces like this. All right, let's wait until it processes all the splines. Okay, so then the inductor is left. And CENOS highlights that we haven't actually defined the flux concentrators. So I'm going to add another role for flux concentrators, and I can select them directly from the screen, or you could do the same also from the list here. Now, so far, nothing has changed. The setup up until the physics point has been exactly the same. Now, the changes start as we go into the physics. Now, we start with the simulation control. So let me input some arbitrary number. So let's say 3-second process time with a time step. Now, the first change you might notice is that here we have actually a new visualization part, advanced setting part, which is called additional results to calculate. Now, previously, if you wanted to enable different visual, like additional visualization fields to be calculated, you needed to go outside in the desk view and do it from a specific button under the visualization block, which was not very convenient. So we actually moved it here. So if you guys want to add any additional calculation to your simulation, such as Lorentz forces, magnetic permeability, or something additional, you simply check the parts here, and CENOS will calculate these additional fields on top of them. Now, the setup for inductors, workpiece, and flux concentrators remain the same. So for the workpiece, we still need to select our material. I'm also going to input some values for the heat losses. For the inductor, again, you only need to input the input value for power. So I'm going to go with 40 kilowatts. And for flux concentrator, you need to define the material. Now, one of the first major improvements within the physics view is actually motion table values. Now, if we go into the motion part, the motion setup remains the same. Now, let's say in this case, I don't want to rotate the part, for example, but I want to move it outside of my part, or in any direction, basically. So how would I do this? Exactly in the same way as I did it before. I select the part that I want to move. I select the direction in which I want to move it. So that would be X, Y, or Z direction. If you want to check, you can zoom out and see the directions colored in the preview window. And previously, we were only able to input constant values. But now, as you see, once we hover over, we can actually define table values. So basically, table value definition for velocity components works in the exact same way as any other table values within CENOS. So if you have already before worked with frequency tables, power, current, voltage input tables, this works in the exact same way. If you have dynamically changing motion setup, mostly in scanning cases, but can be used also in different approaches, if you have dynamically changing motion, then you can define steps for it. So let's start with this 0 time step. Let's input some arbitrary 5 millimeters per second, 5 millimeters per second movement speed up to, let's say, 2 seconds. And then starting from the second, we want to decrease our movement speed, right? So I'm just going to extend this to the whole 3-second process. And here you have it. You have defined velocity table value with changing velocity. In the middle of it, after the second, the velocity will change. Now, you don't have any limitations of how many of these steps you can include, and all the definitions that you put here will be calculated automatically. So basically, If previously you needed to use continue from function to actually simulate dynamically changing velocity values, then now you can do it directly with the table value and without any manual effort from your side. Now, the next big thing, and honestly, from our side, the biggest thing that has been included with this release is the meshing section. Now, right now, once as I have set up my physics definitions, you can see that I don't have only one option. I have two options of how I can proceed. I can click Run, which essentially will enable CENOS to automatically calculate the mesh and proceed with the calculation. But what I can do is I can go into the meshing window. So this is currently the third step that we have developed within CENOS. And this actually enables you to calculate, evaluate, and also modify the mesh within CENOS itself. So now nothing has been generated yet. So I just need to click the Generate Mesh button and let CENOS do the job. Now, beforehand, some, and I suppose most of you remember that for manual modifications of the mesh, we needed to use our built-in preprocessor Saloma, which honestly was a bit tedious to get used to. But right now we have moved most, basically all vital features covering meshing from Saloma into CENOS. So you don't really necessarily need to use Saloma. You can directly use CENOS Mesher, which is a bit easier to use and does not require such a big learning curve. Now, depending on the geometry, of course, the meshing time will change a bit. For very simple cases, it will be quicker. Now, for this pretty standard CV joint single shot case, we see that it takes a bit longer, but still a couple of minutes, and we are good to go. Now, this is, well, yeah, CENOS has generated the mesh. Now, if we want to already inspect the automatically generated mesh, then we already can notice some things. So first of all, we can see that CENOS has actually created a bit of a local refinement. Now, here you can see that around the spline parts, the mesh is actually a bit finer, right? But on the outside, for example, on the top of the CV joint part, and also within the inductors and on flux concentrators, when we don't really need that big or fine of a mesh, CENOS has not made the mesh so small to save on total element count and calculation time to simply make the simulation more effective. Now, additionally, if we rotate the part and zoom in, then you can also see that skin layers have been automatically meshed and generated for both inductor and also workpiece. So essentially all electrically conductive parts. So for that, you also don't need to worry about. Now, currently, this looks a bit blank, and basically, you could potentially already now go with the calculation, but we can still spend a couple of minutes to actually take a look into the mesh that CENOS has generated. Now, first of all, we see here the total element count. Now, this already gives us a good idea of how big or small the mesh is, because it directly correlates with the calculation time needed. If I'm not happy, if I want to make the mesh a bit different, maybe I want to add some additional refinements or change some other parameters, I can easily do that. All I need to do is I need to enable the mesh refinement section. And this gives me essentially full control over all mesh solids, all solid meshes within my simulation domain. So you can see that here I can access separately mesh parameters for each of my system parts and even air. So if I do want to modify how my air mesh looks like, I can zoom out and I can do even that. Now, for example, if I want to go with into the workpiece, then here are I have a couple of choices. Now here I can modify the total element size, the general element size, which has been applied to the whole volume. I can also manually modify skin layer calculations. So you can see that CENOS has taken into account the physical parameters, such as frequency and material properties, to actually choose a skin layer values for you. But again, if you want to have them a bit differently, if you want to change number of skin layers generated, stretch factor, or total thickness, then you can do that directly. If you want to refine something, for example, for some reason, I would like to refine the upper side of my CV joint. What can I do is I simply click on the surface and it will appear right here. So what I do now is I simply decrease the element size, let's say 2 times, and then I need to click the regenerate mesh button to regenerate the mesh. And sorry, and basically, yeah, if you want to restore the mesh parameters to the initial conditions, let's say that you have made the mesh too fine and you want to basically go back to the defaults, you can simply click restore, and you are going to have basically CENOS will restore all all mesh settings as they were assigned automatically before. Basically from the general mesh controls, this is it. For more advanced users, if you want to, then here below you have the possibility to go into more properties. And here, basically, currently you have 2 options. You can either play with the surface gradient, which essentially is a control that defines how quickly elements change from very small sizes to very big sizes. So basically what this does is it defines the gradient by which mesh sizes changes. So if you want to have smoother transition from bigger to smaller elements, you can decrease it. If you want a more rougher mesh for maybe some first iterations or so on, then you can increase it. I can honestly let you in on a little secret that in a relatively short time, we are going to have another release on top of version 4.0. And here we are going to have 2 additional controls for even more control for the meshes that you might have. But I will leave that to the next release webinar. And of course, as some of you may have favored Saloma Mesher from before, from previous releases, then of course you can also click on the advanced geometry editor and use that as well. Now, from the meshing section, essentially this is it. The last thing that I wanted to do within this demonstration is to show actually the last new functionality we have is the so-called CAD file replacement. Now let's imagine I have set up a case. I have seen this. I have defined the physics. I have defined the mesh. I see that the mesh is a bit large. I want to decrease it. Let's say I want to actually I moved quicker than I should, and I want to take a step back, and I want to run initial iterations with a simplified workpiece, meaning that I don't want these splines to be here. I want them simplified so that I can initially test my design, see if it works, and then go into details. Now, before version 4.0, I needed to remake the whole case. I needed to make a new case. I needed to basically make it based on the changed geometries, and so on and so on. But with CENOS 4.0, you no longer need to do this. If you want to change any part of your geometry, it might be simple size changes. If you want to change the diameters of your coils or the respective sizes or relative placements between different parts of your system, or if you even want to swap inductor designs or try different workpiece with the same coil, then you can actually do this without remaking the case. How, you might ask? Pretty simply. You simply go into the desk view and you once more click on load CAD icon. Now here you will get a notification that the geometry is already present. So I will simply overwrite existing results. I will go into the same CAD file folder which I used previously, and I will select the same flux and inductor step files, but instead of the original workpiece, I will select the simplified one. And now I'm going to simply reload the CAD files once more. Again, depending on how complicated your geometry is, it might take a bit longer or a bit shorter period of time for the reloading process to happen. But once it is done, you essentially have a completely new case already set up for you with a different geometry, but with the same geometry roles and physics parameters. Okay, so here we go. We have the exact same case we just set up, but with a simplified workpiece. Now we see that we have geometry roles still assigned. If we go into the physics, we can see that the physics are still assigned, even to the same workpiece geometry. All the physics has been retained, and all you need to do is simply click run to actually to continue the calculation. Of course, the only thing that you are going to need to do is you will need to remesh the whole part once more, simply because the geometry has changed. But aside from that, everything else is retained, and you don't need to spend any more time of building unnecessarily many cases. So yes, from the version 4.0, these were the major updates, and I'm personally pretty proud of them, and I'm happy to be here to share them with you. So I do hope that you like the presentation, and I think that right now we could actually go into the Q&A part. So yeah, for the presentation part, thanks for watching and thanks for joining. And yeah, let's kick off the Q&A part. So I think that we don't really have any questions written in chat, but maybe some of you have some questions or comments or feedback or just general feelings about the new release, whether you have tried it yet or not. So yeah, please raise your hand or simply speak up. Yes, Martin, please go ahead.
So for the changing parts in the geometry, my current workflow isn't that I usually have a workpiece and an inductor and flux concentrators as separate step files, but within one step file. Will that still work if I change the geometry within that one step file? Or will I need to change my workflow so that I export the different parts separately and then import them separately into CENOS to use these features?
Yeah, got it. Yes, it should still work. So as initially, it doesn't really matter if you import an assembly or separate step files, then for CAD file replacement, it also doesn't really matter. The only thing is that if you do have separated your geometries within different CAD files, then once you reload the CAD files, you need to select all of them. So as I just did, I swapped only the workpiece, but I selected also the flux concentrator and also inductor. Because if I would have only selected the workpiece, then the workpiece would be the only solid that I would have in my system. But yes, for assemblies, that should also work in the exact same way.
Great, thank you.
Thank you, Martin. Do we have any other questions? All right, we have a written text from Max. Good afternoon, thank you for your okay. All right, this is actually quite a good question. So a bit general, but still a very valid one. So your company is evaluating the use of CENOS for predictive modeling. However, you have concerns about sharing of data. And for the trial version, you see that there is a constant online connection. Yes, so for the data exchange, this is something that we do try to communicate very often and as strongly as we can. The only thing that we need internet connection for is license checks and support chat. Nothing else leaves your computer. All the CAD files or the simulation files or the parameters and calculated results are stored on your local device and are not shared with anyone else unless you yourself decide to zip it and send them over to us. Yeah, so that's essentially it. I see that yes. We also have my colleague Emils from sales here, if you do want to comment on this, but yeah, I think I covered it.
Yeah, thank you. Greatly covered the question. Nothing is shared apart from the license checks. So no worries, Max.
And thanks for
maybe just to add, like if in case you do want to communicate with the support team and share some of your files, of course we are open to sign any NDAs, although there is already a clause inside of our terms and conditions stating that we wouldn't share any confidential information outside of CENOS in case you do contact us via support and share some information with us.
Yes, very good addition. Thank you, Emils. All right. Anything else from anyone? Yes, Rehman, please.
Hello, everyone. Hello, Elvis.
Hi.
So regarding meshing, I have one question. So after the part is meshed inside CENOS, is there a need to check the quality, or are there any taper elements or anything else? Or is it already avoided inside CENOS?
Yes, this is actually a pretty valid question, and we have had a couple of these already, and I do consider actually giving some kind of a quality assurance output for the mesher. But currently, yes, currently within the mesh itself, you cannot really see what kind of checks have been done and what are the element quality aspects. However, during the meshing generation, we have, like, within the mesher itself, there is a separate technical step which covers the quality optimization. So basically, within the automatic and also afterwards manual recalculation of the mesh, we have a built-in step that checks the quality and changes and updates it or remeshes if it is necessary. So I wouldn't worry about it. If you do want to really check the quality, then we can definitely take a look and see how you can currently get this out manually. But for the live version, you don't really need to worry about it.
Okay, thank you. Yeah.
Okay, last checks, maybe some last minute thoughts or new questions. That is always welcomed as well.
Yeah, maybe one more question.
Please go ahead.
So actually, I already tried this mesh thing, and I tried to open it in Salome. And then I made some change in geometry, one additional face, and I tried to export it back to CENOS. So it said something that there are some extra faces that cannot be exported to CENOS back to CENOS. So I'm not sure. So if we make some changes in Salome, then I mean, can we insert them back to CENOS? Do you understand
Yes.
what I mean?
Yes,
Yeah.
yes, I do get the question. Basically, if you go into Salome and yeah, this is one of the ways, one of the reasons actually why we moved to our own meshing, is that you need to be very careful about what you do and what you export. Because at the point of export from Salome back to CENOS, there is a list of phases and volumes that you need to check or leave unchecked in order to actually correctly export the mesh back to CENOS. And if by any chance or a simple misclick, you manage to either not select everything that you needed or select something too much, then this kind of a problem can occur, yes. In this case, I would really suggest to reach out to the support. And actually, our senior support engineer, Elvis, is already here. So he sees and hears everything. But yes, if you do notice this kind of a problem, then simply send the case, save the case, send that to us, and we can take a look at how to fix it and help you.
Okay, perfect. Thanks. Yeah.
Thank you. Yes, we actually have also a chat from Kartik about last minute joining and all of this. Yes, thanks for joining. And this is actually quite a very good point. I know that the questions arise not at the same time, but yeah, gradually, especially if you actually start and take a look at the new software release. So if you guys have any feedback or any questions after the demo call, feel free to reach out to me, to my colleagues Emil or Elvis, or essentially to anyone with CENOS email address, and we will get back to you with clarifications, or we can even pick up a bit of a more in-depth discussion about the questions that you have. So don't worry if you don't have anything to ask already now. We are open, yeah, 24/7. So if you have something, just write to us. But all right, it seems that most of the questions have been asked and hopefully answered. So I'm going to do the last check. Does anyone have any questions or comments or feelings or simply something that you guys would like to share? All right, then thank you for joining. Thanks for listening. The webinar recording will actually be available in our CENOS YouTube channel after some time. But besides that, yes, thanks for joining again. Have a nice the rest of the day. For some, it might be evening. For some, it might be the whole day. And yes, keep up to updates. Soon we are going to have another smaller release regarding bug fixes and some additional features. So yeah, let's keep in touch. Let's see you in the next time. And yeah, thanks for joining, and then see you guys. Bye-bye.